R code that does too many things all at once is an unmaintainable nightmare. And I know that we've all been taught that we should write clean modular functions, but most explanations stop there. No one is actually teaching you what that means. So that's why most of us probably default to God functions. That's how I call functions that do everything, everywhere, all at once. And I wrote them for years, but eventually I found code patterns that help you structure your functions in a much nicer way. And the payoff is not just the fancy structure, it's actually code that I can jump in quickly to change stuff. And believe me, you will always have to change stuff later on. So today, let's explore code patterns that you can also use to structure your code more efficiently. The best way to learn about code patterns is to take a God function that does too many things all at once and then step by step bring in the patterns that make the function nicer. And in here, I do have a function that does too many things. It is a function that is supposed to generate sales reports, and it will take a bunch of CSV and then load them, wrangle them, filter them, join them with some other data, and then later on give me a whole bunch of summary statistics. So if I execute this whole script, you'll see that I do get a bunch of tables back, and these are the result of a couple of summaries. So what happens in this code is that first we load data, then we do some checks if things are actually there. Once we have that, we do run a couple of cleaning operations, then we summarize things, and we also summarize things for the other data sets. So both of these summaries will give us these data. I'm just giving you a high-level overview here. And then the function returns this thing later on. So that's what we see. Our input for that is inside of my data directory. Inside of the sales directory, I do have these CSV files that have a bunch of data in it. So that's how our data looks. We also have this products data set that just gives us a bit of product categorizations. But the details here are not that important. What is important is that this function does too many things. And the first thing that you want to do is to break up this stuff into smaller functions. This will make it instantly easier for you to figure out what's going on. I mean, if you have been seeing this code here, then you might have even wondered, okay, what's going on here? It's a lot of stuff. But if this were just a bunch of functions chained together and each of those functions has a meaningful name, then things would probably be clearer for you. So that's why, as a first step, we do want to split up such large functions into smaller functions, and each function should only have one concern. That's what people usually refer to as separation of concerns in the programming literature. The terminology doesn't make too much of a difference here, just so that you've heard, you don't want to have a function that has too many concerns. And here this function has the concern of loading the data, checking if stuff is there, then wrangling the data, and then giving an output. So that's too many concerns. You only want to have one concern per function. So the first thing that we can break up is this filtering call. I mean, usually I try to avoid having one diverse verb per function. I don't think it makes much sense to create wrapper for every verb that you have, but it does make sense if there's a lot of stuff going on, and here there are multiple conditions that are kind of defining the reporting scope of the reports that we generate. So it makes sense in this case to wrap this into a new function. So let's create a new function. Let's do filter to reporting scope, and this will be a function that has this body, and it will take as arguments this df raw and then all the other arguments. So this means right now we can put this thing here into our new function call. We'll take df raw and stick this into this function. So let's put this in here, and then let's fill the arguments of this function, and there you go, you have refactored the first stuff. That wasn't too exciting, and here again it was only one verb. You usually want to have multiple things in one function, so that's why for the next function we can combine the next two steps. These are kind of a way to enrich the information with revenue data, or like with revenue and products. So let's call this function that we want to pass this into enrich with revenue and products. And this will get the products data as an input, and it will get the currency as an input. These are two arguments of our main function. And to define this function, we can create a function name with the specific arguments and then fill the body with other stuff that belongs to the operation that we want to do. In this case, this fx rate variable. And then we are going to return the code that we have used before. So that means we can also take this out of the main function because it is now inside of the other function. So this is a nice way to see, okay, we can bundle together things that are supposed to stay together using these functions. And then we can do the exact same thing for this one variable, df growth, and for the other data frame, df summary, we can create one function per each of those. So here, create a new function with a nice name, stick in the code from before, and fill in the arguments with the actual variables you need as part of this code chunk. And the same thing applies for the other data frame. I'll just put in the code here so that you don't get bored watching me refactor this. And then we can delete this stuff and say our return thing is just the functions that we've just created but called. So let's do summary by region and product. Let's stick in the arguments. And then we do the same thing for the other output. So now if I re-execute this thing, we see that we get the exact same output, but our main function looks like less things to worry about at first. We're not done with refactoring this yet, but you see that immediately in the main part of the code, you see that, okay, I can now understand that my first step is to filter to something, then enrich with some information. That's my data set. And then I will summarize or calculate some growth rates based on these things. And the nice thing about this functional approach is that you can jump into these things very quickly by using the tools that your IDE gives you. On Positron, just press Control, click on a function name, and you will immediately jump to where that function is. So that's how you can manage these functions very easily by just first looking at the main function and then jumping to the next function where you want to maybe change stuff. So if you're worried that if you split things up into multiple functions that you won't be able to find stuff, if you use your IDE, that's actually not a concern for you. Okay, so that was basically just shuffling around a bit of code to have it in separate function calls to just separate things to make the main function more easily to digest because it can be digested in chunks now. But what you will notice next is that you have a whole bunch of arguments and these functions are reused over and over again. And that usually happens when you start with one argument, but then you want to have another feature, so you add another argument, and then by repetition, you add way more arguments, and then all of a sudden your main function has like 20 arguments and they are reused all over the place. That can quickly get out of hands, and a nice way to manage that is to bundle arguments together into single objects. And here you don't want to blindly bundle together some arguments, you want to bundle together things that are logically connected. For example, in our generate sales report function, the start date, the end date, the regions, currency, and exclude IDs, these are kind of report settings. Or you can think of this as like a configuration for how you want to generate the sales reports. So that's usually a good subset of arguments that you can bundle together. So what you can do in this instance is to create a new function that creates such a configuration. It's just a simple function, and you first fill it with all the arguments that you want to use. And then what this function returns is just a list of all the things you've just specified. That's also a neat way to define defaults for your configuration. And now all your functions, instead of depending on many arguments, they will just depend on a configuration. Let's just call it CFG as in config for the report. And then we can simply grab the corresponding variable from that list. Same thing is true for this function here. You can notice a little bit of a drawback of this approach. If you reuse this config report object everywhere, even though we only need one of those things, then it might be overkill. There's a trade-off here. You could leave this as currency and then call this function with the object with currency here. Actually, I prefer this way, so here I will just leave it like this. But for the other arguments where I use multiple ones, like for these functions, I'll use the config again, and then I'll just reuse those from the object that was passed into the function. Actually, now that there are less arguments, you can also have the arguments on one line. And then the same thing can be done for the other function. I'm just copy and pasting this in here. And now your function, instead of having all of these arguments, your main function will only have this config reports argument. And all of these variables here can also be removed and replaced with the configuration, and the same thing happens here. Now that we have less arguments, we can also clean up the functions a little bit, or we need less indentations here. So now you see that the main body of our function now comes easier to digest because there's less clutter going on. But of course, in order for this to work, you need to make sure that you actually assemble this configuration object. So let's create this using our make report config function. And in there, we can stick in the things that we have created here. And then in our main function, we simply use this thing. And now as I execute this, I do get the exact same results back. Again, this was a bit of shuffling and repackaging existing code, but it helps you to keep this into a smaller, more maintainable structure. And the cool thing about this is that this is extendable now. If you're thinking, okay, my sales report, it needs to depend on an additional argument, instead of adding an argument to all of those function calls we have seen before, you can simply extend the configuration object, and inside of the other sub functions, you can access that new object from the new configuration. That's a pretty neat thing you can do. Even better, and this brings me to my next point, you can add validations on the configurations on top. It's super helpful if the configurations themselves are also filled via other code logic. For example, instead of creating a function that returns a list of arbitrary things, we don't have any validation of what is actually passed into these things right now. Instead of doing that, we can use the so-called S7 class. I don't want to go into too many details of those S7 things, but if you want to learn about them in more detail, I do have a video that you can check out. The link for that should pop up right about now. But I don't think that you need to watch that video to understand what's going on here, because S7 classes are in fact really easy. By the way, if you enjoy this technical deep dive that shows you how to refactor functions, then make sure to give this video a thumbs up so that I also know that you enjoy this content. So thank you for that. And now let's get back to the video. What you have to do first is to load the S7 package, and then you can create a S7 class using the new class function. Let's call this report config, and this will be a new class. The name of that class is usually the exact same thing as the function name that generates the class later on, or the objects later on, and it will have a bunch of properties. And in these properties, you can stick in a list of things. And in this list of things, we currently want to have all of the same arguments as before. So let's use those things here, and instead of specifying something directly, we do want to specify what kind of data should be inside of that configuration. For example, start date is supposed to be a class date object, meaning the start date is supposed to be a date. S7 classes will automatically validate what you put into this configuration is actually a date. Same thing can be done for the end date. For the regions, we want to make sure that something is of class character, meaning that it is a text. And this is basically the same for all the other properties that we want to have in our class. So what this immediately gives us, if we use report config instead of make report config, what this will give us is that this should work now. Actually, I have to source this thing in order for this to work. We see that we do get some errors here now. We do have to fix that in a second. But what we do have is that this object here, it is created, and you can see these add signs here. In S7, you use adds instead of dollars to access things. So this is why the other stuff is complaining. But the nice thing is here now that if some other code or some user input puts in a text instead of an actual date, then you will immediately have thrown an error because there is now validation attached to this configuration. So that's the cool bonus that you do get from going the extra mile with S7 classes. But again, instead of dollars, we have to use add signs, but that's actually pretty easy to do. In our case, we just use search and replace all. Now, as I source this, we got rid of the error and our code works again. Speaking about code working, we can even add more layers of validation on top of our configuration. Actually, let's get rid of this helper function. We don't need that anymore. What we can do now on this class is to put in a validator that evaluates itself. There is this self argument that we can use inside of these validation objects or inside of these validators. And in there, we can put in logic that is supposed to throw errors when things are wrong. For example, when the end date is before the start date. That could be something that right now is possible because as long as things are dates, S7 won't complain. But if we put in this logic in here now, then we'll have more validation. The idea is that we use an if condition and say that if self at start date, if that is larger or equal than self at end date, then we'll throw in abort error. So we'll use from the CLI package CLI abort. You could also use the base R function stop, but I prefer this because it has nicer formatting. And in there we could say start date must be before end date. And if we do that, then what will become impossible is that my start date is in May while my end date is in March. So as I do this, we see that there is our error message, including typos that I have put in there. So let's fix that start date. And the cool thing about the CLI package is that you can put in some styling in here. So you could throw in an arc class. Don't worry about the details here. I just like to show off the cool things that the CLI package can do. You can add in a bit of styling with these extra notations here. And now as I execute this, we see that we have an error, and that's because I have actually used too many parentheses here. So now as I execute this, we see that, okay, start date must be before end date, and we do have these backticks here now, indicating that these are function arguments. And by the same logic, we could put in more conditions that are throwing in a abort statement when something is wrong. For example, when self at currency isn't euro or USD. Let's fix this validation here, and as a currency, let's do euro. So now if we execute this, you see that currency must be one of euro and USD, not euro. So that's the nice thing about this CLI package, is that we have specified a vector here, and it made this into a nice legible text inside of our error message. But that's a bit besides the point here. I'm digressing a bit. I do like the CLI package, but my main point here is that you want to have a configuration object instead of having all these kinds of little arguments to bundle things together via an object. And you might want to try an S7 class because it gives you a whole lot of extra safety on top of that. Because the nice thing now is that the validations live in one place now, and all the remaining code that you write doesn't have to check that again. This validation already checks that the inputs are the way they are supposed to be. All right, cool. Let's come back to our main function because there is still a couple of things that we could make better. For example, we have nested if conditions, and this is pretty much always a reason to refactor your code. You see here, this is just done as a way to check that the data that was loaded is in order. But now we do have those many indentations, and if there is some other logic that is supposed to happen here, this can get messy really quickly. A nice and easy way to fix that is to put these validations in front of the actual logic. So let's take this code logic and then put this after the conditions. And then we want to make sure that these things here are just throwing error messages when things are not the way they are supposed to be. Right now we're checking the way the things are supposed to be, but if that's not the case, then an error should be thrown, and if not, this code will simply not do anything. So the first idea is that if nrowdf raw is 0, then we'll use the CLI package again to abort with a special error message. In this case, it makes sense to say no data was loaded from the folder path, which is our argument, and this dot path makes it into a path formatting. And then for the other stuff here, let me actually get rid of one curly bracket that we have too much now. Here we check that if all required columns are available. Let's invert that, saying if there is one missing, we can actually calculate the missing columns by using the set difference between required columns and the column names that are inside of our data frame. And then if the length of this thing is larger than 0, then we know, okay, there is something missing, so we need to abort. And here the CLI package gives us again another way to have a nice meaningful error message. We can put in multiple statements here. We can say input data is missing required columns, and then we can throw in a little info icon and say, okay, what are the missing things? Missing is, and then we use the value formatting to make things blue inside of our error message, and then we put in the missing false from the previous calculations. So now we have a whole bunch of error handling here, and what we can do now is to throw this into an extra function just to clean up our code a little bit. We are just using a function that we call check raw sales data. It will get the data, and it will get the folder path because that's what we have used. And then we can create this function. Let's throw this in here. Check raw sales data. It's a function, and the function body is the stuff we have just put in here. And then let's use the arguments over here. So now as we execute this, we still see our error message from before because we have actually left this error here. But now if we fix this, we get our initial code back or our initial results back. But now to just for demonstration's sake trigger when a column is missing, let's use the select function to get only the, or to remove the date column from this. And now as we execute this, we see that, okay, there's our error message and there is our info icon saying missing is date. We could also get rid of multiple things, say date and units. So now as we execute this, we see that the CLI package is so nice that it wraps these two missing things into a nice text for us. But here this was only for demonstration's sake. Now let's just revert our change so that everything works again. So here the idea was to wrap our validations into another functions so that our main function once again is more easy to digest. We have some loading here, we'll fix that in a second. Then we have some checks, then we have filtering, enriching data, and then returning a list of something that summarizes and something that generates growth rates. Again, we don't know the details of that yet, but that's perfectly fine. We can always jump with Control-click to the specific function and check out the details if we need to. Finally, let us clean up our data loading here. And honestly, it's just 2 lines of code here. It might not even be worth to clean this up or to wrap this into another function. But the story that I've left out here is that what people usually do is to run a bunch of validations on the file path or the folder path to check if the data really is there. And that's a smart thing to do. But if I were to do this here, then I would immediately bloat what happens inside of my generate sales report function. So I didn't do that here. But if we were to throw this into another function, there we have some space to add some extra checks. And this also gives us opportunity to check out a pretty cool technique that runs iterations safely, because right now we're iterating over file paths using just the read CSV function, but there's a cool trick to make this safer. What we can do is to create a function that is just using a sales file. It's a function that gets a path, and then it might want to check a couple of things on the path. So we might like to check, is the file actually there where it's supposed to be? Is it not empty? And if neither of these checks trigger a warning or don't stop the calculations, then the read CSV function is called. And now to load multiple files, we can create a load sales files with an S at the end that will get a folder path and then load all the files from that folder. So what we could do in that function is to run a check, is that folder actually there? If it is, then we can grab all the CSV files from that folder. If there are no CSV files in that folder, we might also throw an error. But if not, then we want to iterate over all the CSV files that are there. And we can do this with a safe version of the function that we have just created. You see, we have already seen that this can throw errors. We have defined it that way, but we don't want this to become a showstopper in our load sales files when, for example, the data is empty. Instead, we just like to then not add this empty data to our data frame. So what we can do is to create a new function using the possibly helper function that wraps our initial function. And if anything goes wrong there, we can specify the otherwise argument that it will just return null. And that way we can use our file paths use the map function to iterate over them using our save function. So that way we might get a list that contain nulls or data frames. So we can get rid of all of these nulls by using the compact function, and then we just bind all of the remaining data frames together, and this is then now a much safer version to load all of our data. And inside of our main function we can use this function now pretty easily. Basically all we have to do is to use the load sales files function using the folder path. And now as I execute this, we see that, hooray, everything still works like it did before. But now we have much more modular code, and our main function comes in digestible pieces. If I were to now look into the generate sales report function, I could see, okay, at first I will load data. If I'm curious, how does this work? I can jump into that function, and then I see, okay, this is how it's done. It will do this load sales file. How does that happen? I can click on that function to jump there, and this is how I can inspect my functions even though they are split into pieces. So don't be afraid to split things into pieces, just don't overdo it wrapping like a single verb into a single function unless it makes sense. As we've seen in this video, there are instances of where this can make sense. So with that, we have covered a whole lot of ground of how to avoid creating these God functions that do everything. I mean, we still have a function that does all of the things we previously did, but it is split into a subset of smaller functions that concentrate on doing one thing well, and this larger function just assembles the different parts, and we don't have to worry about how all of these things interconnect because we can just jump into the other functions. Cool, I hope that you enjoyed this video. Let me know in the comments if you did. Also feel free to let me know if I forgot something that's very important. And now with all of that said, I say thank you for watching, and I'll see you next time.